Hi, welcome to part 1 of our lesson on Introduction to Geometry. In this video, we'll cover the building blocks of geometry: points, lines, planes, segments, rays, and distance, which are the basic ideas that form the foundation of everything else in geometry. Let's jump in. Geometry is a branch of mathematics that focuses on the study of shapes, sizes, positions, dimensions, and the properties of figures. It helps us describe and understand the space around us. There are two main branches of geometry. The first is Euclidean geometry, which deals with flat surfaces, the kind of geometry most of us first learn in school. The second is non-Euclidean geometry, which explores curved surfaces, like the surface of a sphere or the shape of the planet. Geometry isn't just abstract math. It's used everywhere, in art and design, in architecture and engineering, in science and technology. Whenever we build, design, or model something, geometry is at work. The subject builds step by step. We start with points, then connect them into lines, extend into planes, and finally move into solids. Each stage adds a new dimension to our understanding. What makes geometry powerful is that it uses both visual reasoning, seeing and imagining shapes, and algebraic reasoning, where we calculate and prove relationships. This combination makes geometry a foundation for logical thinking and problem solving. In the end, geometry is more than just math on paper. It's a language that explains the world around us, from the patterns in nature to the structures we live and work in. One of the biggest reasons we study geometry is because it builds both logical and spatial reasoning. Logical reasoning helps us think step by step and make sound arguments, while spatial reasoning trains us to visualize shapes, positions, and movements in space. Geometry also strengthens our problem-solving skills. Many geometric problems require us to break down complex situations into smaller, manageable parts, a skill that transfers to almost every area of life and learning. Another important point is that geometry connects math to real-world applications, from measuring land to designing buildings, from creating art to programming computer graphics. Geometry is the bridge between abstract math and practical use. Finally, geometry is essential in many careers. Engineers rely on it to design safe structures. Architects use it to create functional and beautiful spaces. Doctors apply it in medical imaging, and fields like computer graphics and robotics depend on geometric principles to model movement and build technology. So, when we study geometry, we're not just learning shapes and formulas. We're developing reasoning, problem solving, and skills that open doors to countless real-world opportunities. In geometry, we start with the most basic ideas, called the undefined terms. These are the true building blocks of the subject. They're called undefined terms because they're so simple and fundamental that we can't explain them using even simpler words. Instead, we describe them and then use them as the foundation for everything else in geometry. There are 3 undefined terms: the point, the line, and the plane. Every other concept in geometry, from angles and triangles to circles and solids, is built from these 3. So let's take a closer look at each one, starting with the point, then the line, and finally, the plane. Let's start with the most basic building block of geometry: the point. A point represents an exact location in space. It doesn't have any size, no length, no width, and no thickness. Think of it as a position, not a shape. We name points using capital letters like point A or point B. On paper, we represent a point with a simple dot. But remember, the dot is just a symbol. The point itself is the idea of a location, not something that takes up space. Everything else in geometry, lines, planes, and shapes, begins with this simple concept of a point. Now, let's talk about the second undefined term in geometry: the line. A line is a straight path that extends forever in both directions. It never bends, and it has no endpoints. A line is made up of infinitely many points. In fact, you can think of it as an endless collection of points lined up perfectly straight. It has no thickness. We draw it with a thin mark on paper, but in reality, a line is just the idea of endless length without width. We name a line using any 2 points on it, For example, if the line passes through points A and B, we can call it line AB or line BA. So a line is infinite, straight, and built from points. The third undefined term in geometry is the plane. A plane is a perfectly flat surface that extends infinitely in all directions. Imagine a sheet of paper that goes on forever. That's the idea of a plane. A plane has length and width, but no thickness. It's two-dimensional, so while we can draw it as a parallelogram or rectangle on paper, in reality it has no edges or boundaries. We name a plane in two ways, either with a single capital script letter, like plane M, or by using 3 points that are not on the same line, called non-collinear points. For example, if points A, B, and C are not on a straight line, we can call it plane ABC. So, a plane is infinite, flat, and two-dimensional, one of the essential building blocks of geometry. Now let's move from the undefined terms to defined terms, starting with the line segment. A segment is simply part of a line, but unlike a line, it has two clear endpoints. That means it doesn't go on forever. It has a definite beginning and a definite end. An endpoint is simply a point that marks the end of a line segment, or the starting point of a ray. Endpoints give structure to what would otherwise be an infinite line. Because it stops at those endpoints, a segment has a definite length. This makes it very useful in geometry because we can actually measure it. We name a segment by its endpoints. For example, if the endpoints are A and B, we call it segment AB. Segments are essential building blocks in geometry. We use them to measure distances, to connect points, and to build larger shapes, like triangles, rectangles, and polygons. Now let's look at the third type of figure built from points and lines, the ray. A ray begins at a single point, called its endpoint, and then extends infinitely in one direction. Unlike a line which goes on forever in both directions, a ray has an endpoint. We name a ray by writing its endpoint first, followed by another point that lies on the ray. For example, ray AB starts at point A and passes through point B, continuing forever in that direction. Rays are useful models for things in the real world that have a starting point but no end, like light rays, arrows, or directions. There's also a special case called opposite rays. These are two rays that share the same endpoint but extend in exactly opposite directions. Together they form a straight line. So remember, a ray has one endpoint, extends infinitely in one direction, and is named starting with its endpoint. Now, let's talk about the concept of distance in geometry. Distance is defined as the length of the shortest path between 2 points. Think of it as the straight line measurement that connects 2 points. One important thing to remember is that distance is always non-negative. We never talk about a negative distance. It's either 0 if the points are the same, or a positive value. On a straight line, finding distance is simple. We just take the absolute difference of the coordinates. For example, the distance between points at 2 and 7 on a number line is 7 minus 2 equals 5. In the coordinate plane, we use the distance formula, which comes from the Pythagorean theorem. Between 2 points x1, y1 and x2, y2, the distance is d equals square root of x2 minus x1 squared plus y2 minus y1 squared. The Pythagorean theorem and distance formula are discussed in greater detail in separate videos. So whether we're working on a line or in the plane, distance gives us a precise way to measure how far apart 2 points are. Let's go over some important terms that will help us describe relationships between points in geometry. First, we have collinear points. These are points that all lie on the same straight line. For example, if points A, B, and C are on one line, we say they are collinear. Next are non-collinear points. These are points that do not all lie on the same line. If you try to connect them, at least one point will be off the line. Now let's move to planes. Coplanar points are points that lie in the same plane. Imagine them all sitting on the same flat surface. Finally, non-coplanar points are points that do not lie in the same plane. In three-dimensional space, this happens when at least one point is outside of the flat surface that contains the others. So remember, collinear and non-collinear describe how points relate to a line, while coplanar and non-coplanar describe how points relate to a plane. Let's quickly review what we've learned about geometry. Geometry is the study of shapes, sizes, positions, dimensions, and the properties of figures. It comes in two main forms: Euclidean, which deals with flat surfaces, and non-Euclidean, which explores curved ones. We study geometry because it builds logical and spatial reasoning, strengthens problem-solving skills, and connects math to real-world applications. It's also essential in many careers, from engineering and architecture to medicine, computer graphics, and robotics. At its foundation, geometry begins with three undefined terms: the point, the line, and the plane. From these, we build segments, rays, and solids. We also measure distance and describe relationships using terms like collinear, non-collinear, coplanar, and non-coplanar. So remember, geometry isn't just about shapes on paper. It's a language that helps us reason, solve problems, and understand the world around us. That brings us to the end of Part 1, Introduction to Geometry. In Part 2, we'll dive deeper into the world of geometry by exploring angles, shapes, areas, perimeters, and volumes. These concepts will build the foundation we need for more advanced topics like triangles, circles, and coordinate geometry.
For more videos like this and other learning resources, follow and subscribe to our channels. And if you need tutoring help on this topic, visit our website at www.keydemics.com to request a session. See you next time!